Okay, so today we are going to look at trig identities, sum and differences of angles. Our learning intention is to understand the knowledge of, to gain the knowledge of the sum and differences of angles, and the skill in using these identities to solve trig problems. So we'll be successful if we can derive the sum and difference expansion, and if we can correctly use the sum and difference expansions to trig identities to solve problems. Okay. So using the unit circle, we have the x-coordinate being cos x and the y-coordinate being sine y. If I have a point, let's say it's P, well that point is going to be, the coordinate's going to be cos A and sine A. And this angle here, let's call it angle A. Okay. If I have another point, let's call it Q, and it's going that's coordinate's going to be cos B sine B. Okay. And if I was to draw a line here, this angle here would be angle B. Yep, because it made those triangles. So that means that this angle in here would technically be A minus B. That angle just in here, just in the middle bit, that'll be A minus B. So, okay. If I then draw and connect to those, align and connect to those 2 points, I create a triangle, a non-right angle triangle with the angle, the included angle being A minus B. Okay. So let us calculate, let's try to figure out how we get this identity. Okay. So using the distance formula, okay, so we're going to say that the distance of the P and Q, the distance of PQ, well, that's going to be subtract the x-coordinates from each other and square it, and then add that to the difference between the y-coordinates. Yeah, and this is from the distance formula. Okay. So our x-coordinate is going to be cos A, and we're going to minus it from cos B, and we're going to add it to the difference in the y-coordinates. Sine A minus sine B squared. Okay, now we're going to expand that. So obviously this means cos A minus cos B times by cos A minus cos B. Yep. And obviously this is sine A minus sine B times by itself again. So when that happens, we square the first term. So cos A times cos A is squared cos A. Multiply the two terms together, so it's negative cos A cos B, and double it. So minus 2 cos A cos B, and then square the last term. So it's cos squared B. And it's the same, so we're going to square this, so we're going to add it to sine squared A. Then we're going sine A minus 2 sine A sine B, and plus sine squared B. Okay. Now, using the Pythagorean identity, that cos squared x plus sine squared x equals 1. Okay, so I'm just going to rewrite this. So I've got cos squared a, that's that one, and I'll connect it with this sine squared a. Yeah, I'm then going to write that cos squared b, and next to this sine squared b. Okay, and then I'm going to collect this negative 2. And I've got cos a cos b, and then plus sine a sine b. Okay. Now this cos squared a plus sine squared a is just 1. This part here is just 1. Which leaves us that. Okay. So now using the cosine rule of c squared equals a squared plus b squared minus 2ab cos c, and just looking at this triangle POQ, let's say POQ, we get PQ. Yeah, so that's a c squared. So PQ. Now remember that this is the unit circle, so the distance from the center to the diameter is 1. So that's A, and then that's B, minus 2AB. Now cos, now that middle bit was A minus B. Okay, these are identical because that was PQ and that's PQ. So what we can do is we can write it like this, or equate coefficients. That's what we're doing. We're equating coefficients. Sorry. Okay, so this rule's here and that rule's there because they equal each other. Obviously, this cancels each other out, so it just leaves us with cos A minus B equals cos A cos B plus sine A sine B. And that's the first identity. Okay. I want you to notice the fact that we have cos, we have the angles subtracted from each other, and that will give us cos, so cos A, cos B, these are the same, and sine A, sine B, right, with the sign changed to a positive. Okay. Now, a lot of your images or in your books will also have, they'll probably move that P over to here, so it has a larger kind of image to look at. That's fine because cos is an even function, so cos of negative x is the same as cos of x. Okay, I just want to show because it's an even function. Okay. Right. So what happens now if we've got a new point? Okay, same unit circle, but new point, cos A, sine A. And we have a point Q, but it's in the fourth quadrant. Okay, so technically it's cos B, negative sine B. So if this was this angle here, because that's my first point, this was angle A, and then this point here was angle B, then the whole angle, this entire angle, has to be A plus B. Now, using the same ideas, let's join the coordinates together. Okay, using the distance, so distance formula. Okay, we get PQ squared. Well, that's cos A minus cos B all squared plus sine A minus sine B squared. So that becomes cos A minus cos B all squared plus sine A plus sine B all squared. Expanding, square the first, we get cos squared A. Multiply it together, we get negative cos A times cos B, so double that. Negative 2 cos A cos B. Squared last time, cos squared B. I'm going to add it to sine squared A. Multiply them together and double it. 2 sine A sine B. Square the last term, sine squared B. All right. Remember, so getting sines and cos, sine squared A plus cos squared A plus sine squared A. Remember then those equal to 1, so let's collect that. So 1 plus 1. I'm going to have, let's take a positive. 2, and what I'm going to put sine A sine B, yeah, minus cos A cos B. Okay, so I took out a positive version over here. So that's that. Now, obviously using the cosine rule. Okay, so we get PQ squared equals A is 1, B is 1, minus 2 lots of AB cos A plus B. Yeah, these are similar. So we get that cancels. So I'll write it up again. Okay, equating coefficients. So we get, let's go negative 2 cos A plus B equals 2 sine A sine B minus cos A cos B. If I divide it by negative 2, I get a negative. Okay, and now multiplying both terms by negative, I get cos A plus B, the sum of two angles, is, now I'm going to rewrite it the other way around because this now would become positive, and this would become negative. Okay, so there's your other identity. The cos of adding two angles, A plus B is cos A cos B, the same terms, minus sine A minus sine B. Now, alternatively, what you might see in some textbooks, is if we have proven, so in your books, you might see this proof as well. So if we've proven that cos A minus B is cos A cos B plus sine A sine B, what we're going to do is we're going to replace minus B with for B. So we're going to substitute minus B. Okay, so we get cos A minus B equals cos A cos negative B plus sine A sine negative B. Okay, so two negatives become a positive, so we get cos A plus B, which is what we wanted to do. Now, cos A stays the same, and so would sine A at this stage. Okay, now, as I said, cos of negative B is the same as cos B because it's an even function. And to remember what even function is, so this is the cos curve. It is reflected as a reflection of symmetry around the y-axis. So really I can write this as cos B. But sine of negative B is the same as negative sine B, as it's an odd function. So there's our sine curve, and an odd function reflects about the origin. So instead of writing sine A, I can write sine B and multiply it by negative. So it changes that positive to a negative. And that's the proof that that's the same proof as what we came up to before. Okay, so that's the same as what we came up to before. Okay, so that's cos A minus B, cos A plus B. Okay, now we're going to do sine A plus B. Alright, now we know that sine, using our complementary angles, we're going to, we know that, so sine is 90 minus theta, or cos is 90 minus theta. So what we're going to do is we're going to substitute 90 minus A into cos A minus B. Okay, so cos A minus B is equal to cos A cos B plus sine A sine B. Okay, so we're going to substitute 90 minus A. Okay, and we're substituting this for A. So we get cos 90 minus A minus B equals cos 90 minus A cos B plus sine 90 minus A sine B. Okay. Now let us just, with this part, let's keep the 90 out here, and let's just factorize this. So I'm taking a negative, so it's going to be A plus B. Okay, I'll come back to that. So, and then that would stay the same. Let's just write that down. So using our complementary angles, cos of 90 minus theta is equal to sine theta. Yeah, so using our complementary angles. So this becomes sine A plus B. So cos 90 minus A, well, that's just going to be sine A. And then sine 90 minus A, well, that's going to be cos A. Yeah, and that's our third identity. So notice here, we've got sine A plus B. It will give a solution of sine A cos B plus sine B cos A, or cos A sine B. So, because they're multiplying, when you multiply two identities together, it doesn't matter which order it comes in. So that's not too bad. But usually we would write it as sine A cos B plus sine B cos A. So when we're adding two angles in sine, it's sine and cos. The symbol stays the same. Okay, same thing. So now we've got sine A minus B, and we're now going to substitute once again negative B for B. So substituting negative B for B. Okay, so we get sine A plus, we're putting negative B, that's sine A cos of negative B plus cos A sine negative B. Okay, so positive and negative become a negative. Cos of negative B is the same as cos of B, so that's sine A cos B. And sine of negative B is negative sine, so now it's becoming negative sine B cos A. And that is the fourth identity. Yeah, so when you were subtracting two angles in sine, it's sine and cos of each angle subtracted minus. The symbol stays the same. Okay. Alright. Now we have tan A plus B. Okay. Now we know that tan theta equals sine theta over cos theta. Okay, so if we have tan A plus B, we would have sine A plus B over cos A plus B. But we know that sine A plus B is sine A cos B plus sine B cos A. And we're going to divide that by, well, cos A plus B, we've figured that out to be as cos A cos B minus sine A sine B. So what would occur, the question comes out, now we've got that, the question comes as, what would happen if we divide top and bottom by cos A cos B? Okay, so I've got sine A cos B plus sine B cos A over cos A cos B, all over, I'm just going to write it like this, all over cos A cos B minus sine A sine B over cos A cos B. Okay. What I'm going to do is I'm going to do the bottom part first, right? Well, if that was the case, this would cancel out with that. So I would get 1 at the front. Now, that's for that part. That's going to be 1 minus sine A over sine B, or I'll write down sine A over sine B over cos A over cos B. Yeah, and that in itself is 1 minus tan A tan B. Okay, now let's do the numerator. Okay, so if we have sine A over cos B, so this is sine A over cos B over cos A. Sorry, that should be a plus there. Yep, cos B plus sine B cos A over cos A cos B. Yeah, well, that cancels out that. So what we get is sine A over cos A. And this cancels out that. That's sine B over cos B. Yeah. So we know that sine A over cos A is tan. So we get tan of A. Sine B over cos B is tan B. Yep. And we figured out what the numerator is. The denominator is. That's 1 minus tan A tan B. So tan of A plus B is equal to tan A plus tan B, 1 minus tan A tan B. Okay, and that would be our fifth identity. All right. So, what happens if we're going to substitute minus B for B? Okay, so tan A plus B was tan A plus tan B, 1 minus tan A tan B. Okay, we're going to substitute negative B Okay, so positive and a negative become a negative, so that's tan A minus B. Tan A stays the same. Tan of negative B is negative tan B. As a negative, two negatives become a positive. Tan A tan B. And there is our last identity of the sum and differences of angles, right? So as a summary, we have cos A minus B. The causes stay cos, sine, sine, but the symbols change. Okay, sines, they become sines and causes, but the symbols stay the same. Tan, we always have the same symbol at the top, tan A, tan B, but the denominator becomes 1 plus or 1 minus tan A, tan B. So the symbols change. Okay, so they're the sum and differences of trig identities. Okay, if you're doing the 2020 and beyond HSE exam in New South Wales for extension, there we go. You don't need to remember them because they are on your formula sheet, but it's only the positive versions. So you do need to kind of understand how to get the negative versions or what changes between the positive and the negatives. Okay. All right. Let's do some examples from it. All right. We want to find expansion for each expressions. Okay, we've got a sine, we've got two angles. We've got x, 4x and 5y. So the sine of A plus B, we said that's sine A cos B. The symbol stays the same. Sine B cos A. Okay. Well, in this case, A equals 4x and B equals 5y. So that's going to be 4x. So the sine of 4x plus 5y is sine 4x cos 5y plus sine 5y cos 4x. Okay. Now here we've got cos. We're adding two angles. So that's going to be cos A, cos B minus sine A, sine B. And in this case, A is going to be 3z and B is going to be 4 alpha. Okay, so cos of 3z plus 4 alpha is equal to cos 3z cos 4 alpha minus sine 3z cos 4 alpha. Okay, so tan 45 plus b. So tan of adding two angles together is tan A plus tan B, 1 minus tan A tan B. Okay, in this case, A is going to be 45 and B is going to be B itself. Okay, so tan of 45 plus tan B over 1 minus tan of 45 tan B. Now, while we're here, it's really important to remember that tan 45 is equal to 1. So if that was the case, right, then continuing on with this problem, this tan 45 is 1. That still says as plus tan B. There's that 1. Now, minus tan 45 was 1. 1 times tan B is tan B. So the final solution is 1 plus tan B, 1 minus tan B. Okay. We want to simplify sine A cos A minus B plus cos A sine A minus B. So I look at this and I go, well, this is a sine A cos B plus, let's go, sine, that was B, cos A. Well, that is really sine A plus B. Yeah, and in this case, if A equals A and B equals A minus B, then the solution is going to be sine A plus A minus B. A plus A is 2A. And that's us. So this whole thing simplifies to sine 2A minus B. Okay. Looking at the second example, we've got cos. So let's say if A equals 60 and B equals 30. Okay. So we've got cos A cos B minus sine A sine B. Well, that is equal to cos cos sine sine, that's going to be a cos. Because it's a negative, it's going to be A plus B. Okay. In this case, A is 60, B is 30. 60 plus 30 is 90. Now, cos of 90 is 0. Because there's your cos curve. Yep, so there's 90. That's cos of 90, which is 0. So there's that final answer for that. Okay. Here we've got let's say let A equal 2 alpha and B equal alpha. So we have, technically we've got tan is a subtraction, so A plus B. Yeah, and in this case we've got tan 2 alpha plus alpha, well, that must be tan 3 alpha. Okay. All right, we want to find the exact value of sine 38 cos 22 plus cos 38 sine 22. Okay. So, it's a sine cos. So we know that it's going to be a sine. It's got A is going to be 38 and B is going to be 22. Okay, now because of this situation, it's a plus, so that's also going to give it a plus in the center, right? So 38 plus 22, that is 60. So that's sine of 60. Now remembering our exact triangles, yeah, an equilateral triangle of 60 degrees, that gave you square root 3. So sine opposite over hypotenuse, so the final answer is 3 over 2. Okay, so cos 165. Okay, well that's going to be the same using our complementary angles. So cos theta is the same as sine 90 minus theta, and in this case theta is 165. So we've got sine of 90 minus 165. That's going to give us sine of negative 75. Now, because sine is an odd function, well, that's the same as negative sine of 75. And we like this because 75 really is, if I just write negative there, is sine of 45 plus 30. Okay, and we know when we're adding two angles in sine, so I'll just keep this negative out here, right? So this is going to be sine something cos something. We're adding, so it's going to be plus sine something cos. Yep, and that's going to be 45, 30, 30, and 45. Okay. Now, getting our exact triangles, using this one up here. Okay. And the other triangle we have is 1 and 1, square root 2. Okay. So exact triangle 1, triangle 1, triangle 2. So negative sine 45 is 1 over square root 2. Cos 30 is square root 3 over 2. And we're going to add that to sine 30, so 1 over 2, and cos 45, 1 over square root. Okay, so that's going to be square root 3 over 2 square root 2 plus 1 over 2 square root 2. Okay, so we get negative 3 plus 1 over 2 square root 2. And now, because I want to have a rational denominator, I'm going to multiply it by square root 2. So that's going to give us square root 6 plus square root 2. 2 times 2 is 4. And that's your final answer with the negative at the side. Yep. Okay. All right. Last page of examples. So if we have A and B, and they are angles between 0 and 90, sine A is 3/5 and tan B is 7 over 24. So the first thing I drew is draw two triangles. Okay. So if this was A, sine A is 3/5, so opposite over hypotenuse. So that this, using Pythagoras theorem, that must be 4. Okay. And if this was B, tan is opposite over adjacent. Okay, so 7 squared plus 24 squared is 625. That is a hypotenuse of 25. Okay, so if we want to find what sine A minus sine B, well, that's sine A cos B minus sine B cos A. Okay, using our triangle, sine A is 3/5. Cos B is 24 over 25. We're going to minus sine B, which is 7 over 25, times cos A, 4/5. Okay. So we can just type that into our calculator, just to speed things up. And we get 44 over 125 is the answer for that. Okay. Same triangles. We've got cos A plus B, so that's going to be, I'll do it over here. That's going to be cos A cos B. That's plus, so we're going to minus sine A sine B. In this sense, cos A was 4/5. Cos B is 24 over 25. Sine A is 3/5. Sine B is 7 over 25. Plug that into your calculator. We should come up to the answer of 3/5. Okay. Now tan A minus B is, that's tan A minus tan B. 1, change the sign, plus tan A tan B. Tan A is 3/4 minus tan B is 7 over 24, all over 1 plus 3/4 times 7 over 24. Plug that into the calculator and we get 44 over 117. Now, obviously in an exam, depending on how much time you have, we really should be doing this showing every step rather than just going to the solution, but as I'm running out of time, I'll just use the calculator to do this. Okay, thank you very much. And that is the sum and differences of angles. Thank you.